Okay, so again, here we are. We've got our 3-7 homework sheet. We're going to run through these 6 together. This reviews solving with the distributive property. We can also use the box method, but as we go through this, I'm going to show you that we are going to be doing, sorry about that, we are going to be doing the distributive property for the ones that are a little bit easier, like single distribute, but we'll do the box method for the ones that are a little bit more challenging, like problem number 2, okay? So let's start distributing. My first step is to bring that 3 that's outside the parentheses to everything in the parentheses. So what's 3 times x?
3x.
Beautiful, 3x. What's 3 times 4?
12.
12, so plus 12. I just bring that piece down. All I did was rewrite that a different way. These are 2 equivalent expressions. Then I'm going to bring the 5x plus 14 down. Remember, when you have variables on both sides, you need to get rid of one of them. The recommendation is to get rid of the smallest one, but that doesn't always work. Sometimes you have to do a different method, but here it's going to work. So I can get rid of the smallest one, so I subtract the 3x.
1.
And keep in mind, when I subtract the 3x, I mean I'm subtracting it from both sides. If you have a hard time with what I mean by both sides of the equal sign, draw a line down the center so you can see it. Whatever I do to one side, I should have a duplicate of that thing on the other side. So on the left, I'm left with 12. On the right, what's 5x minus 3x?
2x.
2x plus 14. And then I can continue to solve. I need to get the variable alone. So my next move would be to remove the 14. Again, from both sides. Ooh. 12 minus 14. Negative 2 equals 2x. Then I can do my final step of division. And negative 1 is x. Final answer on that one. Worked my way through kind of a lot of steps. So it's important to take your time when you work through this. Problem number 2. I have to distribute the negative 4. And a lot of people are like, well, that's minus 4. That says minus 4. It does say minus 4, but we treat it like a negative 4 because this is plus negative 4. Right? So a minus is like plus a negative. So I distribute that through. This is 5x plus negative 4x, so that's minus 4x, plus negative 4 times negative 3. What's negative 4 times negative 3? Positive 12 equals 8. And now here's another thing that people get a little bit weirded out by, because the 4x or the 5x minus the 4x, I have 2 variables. And over here in problem number 1, I had 2 variables. And so I had to get rid of the 3x. But that was because they were on both sides of the equal sign. Here, I just combined them. It's 5x minus 4x. I'm not getting rid of it. I'm just simplifying. What is 5 minus 4? 1. So this is like 1x, but I don't need to write the 1. I can just write x. 5x minus 4x is 1x or x. Then I bring down everything else. How do I solve? I'm not going to get rid of the 8 from both sides because it's already by itself. But I want the x by itself, so I'm going to get rid of that 12. So x is negative 4, and I'm done with that problem. All right, so we're getting spicy in problem number 3. In problem number 3, I'm going to have to simplify that double parenthesis. And one method to do it is the double distributing, but an easier method is to do the box method. Yep. So what I like to do is take this here. I'll move my sheet up now. Take that there and draw the box. So x and 2 go along the left. X and 3 go across the top. X times x is x squared. X times 3 is 3x.
Oh wait, 2x.
2x.
3x.
And then 2 times 3 is 6. I'm always going to end up with, when I do these problems, now this isn't always, but when I do these problems that we're working on, I'm always going to end up with something that I can combine. And you're right, that is 5x. So when I add those together, that's 5x. So I write this as x squared plus 5x plus 6. X squared plus 5x plus 6. So I'm going to go ahead and bring down the other side. Do you notice something fishy about this?
But they're equal on both sides.
They are equal on both sides. Who remembers what happens when you have the exact same thing as on both sides?
Wait. You get rid of the.
Everything cancels out. Gone and gone and gone and gone and gone and gone. I'm left with 0 equals 0. When does 0 equal 0? Always. What's my answer?
0, 1.
All real numbers. 0 always equals 0, so my solution for that is all real numbers. Remember, we could do that fancy R. You could write that either way. Do you guys remember what it would look like if it was no solution? Do you remember what it would look like with no solution? Yeah.
Equal sign slash.
Well, what would my answer look like instead of 0 equals 0? What might I get if it was a no solution?
0 equals 3.
Perfect, yeah. So if you ended up, this would be an alternate situation, and this is kind of a review from before. This is an alternate situation. So if I got 0 equals 3, that would be no solution. Yep. Just kind of a side note off to the side, keep in mind, if it's something that will never be true, it's no solution. If it's something that's always true, it is. Yes, and then you could do an equal with no, with a slash through it. Yep. Okay. Up with number 4, what do? Distribute 4x minus 4 equals 12, and then solve. Tell me how to solve.
You subtract or you add the 4.
Add the 4 on both sides. Remember, if you don't know what I mean by both sides, then draw a line through the equal sign and make sure that you have duplicates on each side. So 4x equals 16. Divide by 4, x is 4. Final answer.
I got a little line somewhere.
We're all just trying to learn here.
All right. Up next, I've got another one where I'm going to have to do the box method. Another situation where I have a double distribute.
Oh, Anita, run.
So I'll
English?
draw the box. It's a 2 by 2, right? 3x minus 1 down the side, x and 5 along the top. Then I multiply. That's 3x squared. What's 3x times 5?
3x squared.
No, I got the 3x squared. 15x, yep.
Shut up.
Negative 1 times x.
Negative 1x.
Negative 1x. Negative 1 times 5.
Negative 5.
Negative 5. Then I look on the diagonal, on the problems that we do, I look on the diagonal, and that's negative 1 plus 15 is 14x. So when I rewrite this one, it's 3x squared plus 14x minus 5. Then I'll bring this other side down.
Cross the 3x.
3x squared plus 11. And remember what I said last time we were talking, that this isn't always going to be the case, but right now it's the case. We're going to end up with an x squared term that matches on both sides, and if I have a matching thing on both sides, I can just cross it out. So I'm down to 11 equals 14x minus 5, and now I need to get the x alone. How do I do it?
Add the 5.
Add the 5, add the 5. I got a question on that one. So 16 equals 14x. I'm already feeling a little nervous about this because I'm foreseeing, yet no solution is not an option because I have an x there.
Multiply 2.
I divide by 14
And do 1.
and I get this funny thing that's not divisible. It's okay. I'm going to go with what Ty said. I'm going to divide the top by 2, divide the bottom by 2, and I get 8/7 for x. Some people get bothered by fraction answers like that. We shouldn't be. It's all right. They are okay. If you'd prefer, you can plug that in your calculator and get the decimal answer, but it's going to be an ugly, non-repeating, non-ending decimal, and so it's just going to be, actually it is a repeating decimal, but it's an ugly repeating decimal, so we can just leave it like that. In fact, I prefer to write it like that, okay? Last problem that we're going to work through together here is just a distribute, but I have to distribute on both sides. So I bring the 5 through on the left, and I'll bring the 4 through on the right. So I'm just rewriting this first thing as 5x plus 15 plus 9. I just bring the 9 down. Equals 4x minus 28. I'm in another situation where I've got terms to combine.
That would be.
They're on the same side.
Or 24.
24 it is, yep. So this is 5x plus 24 equals 4x minus 28. And now I need to solve. Again, I've got variables on both sides. And I'll get rid of the smaller one first, so I'm going to minus the 4x. Again, subtracting the smaller one isn't always going to be the best option, but a lot of times it is, and in this case it is. So that's 1x. Do I need to write the 1?
No.
No.
It's nice though.
It is nice because it's kind of a filler and it helps you remember what you did. I subtracted there, okay? Now I need to get the x alone, so I'll subtract the 24 again on both sides.
2.
Eek. Negative 52. Yeah, it looks like negative 52 to me. And then I bring down the x. Again, I don't need the 1 in front, so I can stop right there, and I'm done with that problem. Okay, what I'd like you guys to do is put this in the basket, because there's another side to this that I want to give it back to you when we work through our next notes, and then get out your green packet. Get out your, yep, put that right in the basket on top of the microwave, and then get out your green packet.
Do you like me? Get away.
No, you.